Hi, my name is Sarah, and today I'll be exploring the development of pi and its impact on mathematics, in particular looking at the contributions of Archimedes of Syracuse. To demonstrate the meaning of pi, Stephen Bogart for Scientific American asks us to, using a compass, draw a circle, take one piece of string and place it on top of the circle exactly once around. Now straighten out the string. Its length is called the circumference of the circle. Measure the circumference with a ruler. Next, measure the diameter of the circle, which is the length from any point on the circle straight through its center to another point on the opposite side. The diameter is twice the radius, the length from any point of the circle to its center. If you divide the circumference of the circle by the diameter, you will get approximately 3.14, no matter what size of circle you drew. Pi, represented by the Greek letter for P, is a very recognizable symbol used in many mathematical formulas. But what does it represent? Pi is a constant value which represents the ratio of the circumference of a circle to its diameter. Pi is an irrational number, meaning that its decimal value neither ends nor becomes repetitive. For this reason, it is important to have Pi's symbol as shorthand, as well as an approximation such as 3.14 or 22/7 to be used for everyday calculations. Pi is a value utilized to solve mathematical equations when concerning the lengths of arcs or other curves, the areas of ellipses, sectors, and other curved surfaces, and the volumes of many solids. It can also be used in some physics formulas. When looking at circles, the area is equal to 2 times pi, multiplied by the radius squared. The circumference or the perimeter of the circle can be solved with pi multiplied by the diameter. Other shapes pi is significant in calculating include spheres and cylinders. So, who is Archimedes? Archimedes was an academic who lived in the Greek city of Syracuse during the 3rd century BC. He is regarded for his contributions to the fields of mathematics, physics, engineering, astronomy, and finally mechanics. The mathematician had stated that he wished to have a sphere inscribed in a cylinder carved on his tombstone, paying homage to his mathematical contributions. He died an untimely death after being killed by a Roman soldier in the chaos of the final fall of Syracuse. Archimedes' contributions to the modern understanding of pi were built upon the past works from the Babylonians and the ancient Egyptians. The Babylonians built their approximations of pi from their work with hexagons, while the Egyptians outlined their approximations in the Rhind papyrus, approximating the value of pi to be 256/81, or about 3.16045. Archimedes improved upon these historic approximations. Archimedes is credited for both proving the ratio of the area of the circle to the square of its radius is the same constant, and outlining the value of pi to the greatest accuracy of this date, falling between the bound of 223/71 and 22/7, or an average value of about 3.1418. He did this by applying his prior geometry knowledge to polygons inscribed and circumscribed about a circle. Archimedes primarily used the laws of trigonometry, namely the use of sine, cos, and tan, as well as the Pythagoras theorem during his work. Using a circle with a radius of 1 to ensure simplicity, Archimedes began with the inscribed and circumscribed hexagons, much like the Babylonians. He continued this same process with the use of dodecagons, 24-gons, and extended as far as 96-gons to finalize his findings. As the centuries continued, Chinese, Indian, and Arab mathematicians continued to utilize Archimedes' methods in defining the value of pi, extending upon his findings and further decimal places rather than improving upon his practice. 500 digits of pi were identified in the beginning of the 20th century, and due to the development of advanced computers, we now know more than the first 6 billion digits of pi.